All right, this is lesson 5.09. It's called Transversals and Angles. And before you move on, if you want to pause the screen, I like this visual right here. We're going to go through these words and what they mean. So if you want to draw this with some markers, it might be helpful. Notice it gives you colors, so it tells you the corresponding angles are in red here. This is an example. And you can see each color there. So just pause that screen. This is a good thing to know. Another thing for me to point out before we move on is it also tells you in parentheses here what those angles mean, which is pretty important. So in the red, if these are called corresponding angles, then those would be equal. In other words, if this was 40 right away, you would know that this would also be 40. Notice they're all equal here except for the inside interior. So those are some good facts you may want to write down. Okay, let's go through some more in depth of those angle relationships. So notice here that you've got this beautiful picture, and these lines right here represent parallel. So that means if you have two parallel lines, now they have to be parallel. This relationship, the relationships we're about to talk about, will not work unless they're parallel. And it says they're cut by a transversal. So a transversal is right here. It cuts through those lines, and it's going to create angles. It's going to create angles 1 through 8 in this picture. And then it goes through all of these words that are important to know. It says, hey, we've got some vertical angles, some exterior angles, so corresponding angles. What does that mean? So vertical angles, if you look at the examples, would be like 8 and 6. Vertical angles to me, when I draw it out, looks like a bow tie. It goes like that. They go across from each other, share the same vertex, but they go across from each other, kind of like a bow tie. And that means that they have equal angle measurements. Okay, so you may want to write that down in your notes. Adjacent angles, if you look at 8 and 5, look at 8 and 5. Adjacent means next to. So adjacent angles means next to each other. And in this case, they may or may not be equal to each other. In this case, they're not. So keep that in mind. Here they are equal angles. Here they're not necessarily. All right, alternate interior and alternate exterior. So when you have a shape, here's our two lines here. Okay, anything inside those lines right here is called interior. So I'm going to draw that out. I'm just going to write interior here so you can see it. And imagine now if I drew this line through it, this is my transversal, it doesn't matter. Everything inside those two lines are still interior. Exterior would be everything outside of those two lines that I'm doing in blue. So exterior would be like the blue, outside of those parallel lines. Now, with that said, if it's alternate, remember alternate means not next to each other. So if you look at this picture, 4 is inside the parallel lines. If you go across and you look, 7, they're alternate. They're not next to each other, but they're both inside. Okay, this is going to be example number 1. So if you want to put this in your notes, go ahead and draw that picture. You might need to pause the screen. Okay, in this lesson, you learned a couple of things. Notice something here. So we want to notice a couple of things when we're looking at these. I think of them like a puzzle. Notice that this is a triangle. And we know that triangle, the angles always add up to 180. So let's go ahead and figure that out. If we know that we have 60 and we have 20, we can do 60 plus 20 plus whatever this angle is. I'm going to make it x. Has to equal 180 because it's a triangle. So 60 plus 20 is 80. So 80 plus something is 180. So that means my something here would be 100. So this has to be 100 degrees because the triangle angles have to add up to 180. Now I want you to notice something else here. These two angles, angles 1 and 2, make a straight line. Those are called, it's a fancy word for supplementary. Learned about the word supplementary. So if that's the case, we want to take 100. We want to add it to whatever that angle is. Let's go ahead and make that angle y. And supplementary means they have to equal 180. So if we subtract 100 from both sides, that tells us that our answer would have to be 80 degrees. So angle 2 has to be 80. Make sure you have your degree sign. Angle 1 had to be 100. And those are your answers. All right, this is example 2. You may want to pause the screen so you can write it out. And it's kind of complicated here. There's a lot going on. Okay, so it's like a puzzle. We want to look at it and we want to see what could we figure out? What do we notice? We can't really start with 4 and 3 or anything down here because you just don't know much about it. But look right here. What do you know about 1, 10, and 1? Notice how those make a straight line right here. See how that's a straight line? And remember, if it's a straight line, those are called supplementary. And remember, supplementary means that they add up to 180. So I know that 180 is always equal to 110 plus whatever that angle is. So if I subtract 110, that tells me that angle 1 has to be 70 degrees. Okay, so 70 degrees. Okay. So now let's see, what else do we notice? Notice down here, we have another straight line with those two angles attached to each other. That's also called supplementary. That means that we have to have those added up, we can add those to 180, so 115 plus whatever that other angle is has to equal 180. All right, so I'm taking 180 and I'm subtracting what I know, which is 115, and that gives me 65. So that means that this little space has to be 65. We're getting a little bit closer here. Okay, what else do we realize here that we could use? Well, we also know that, look what I'm doing right here. This is a red. What I'm doing in red is a triangle. And we know a triangle adds up to 180. See, this is like a puzzle. Remember this. It's kind of hard. It's like a puzzle. Okay, so I'm going to take 70 plus 65. That's what these are. And that gives me 135. And when I do 180 minus the 135 of what I've already used, gives me 45. So in here, this is 45 degrees. All right, so the next thing I notice is that 7 and 6, look how they're kind of close to each other, and they're kind of make a bow tie if you think about it here. Look, that's an example of a vertical angle. So when they're vertical, that means they are congruent or equal. So if one is 45 degrees, the other one would be 45 degrees. They have to be the same. All right, one step closer. Now this is pretty tough. I want you to realize a couple of things here. We're almost done. Notice that line M and Q here are parallel. So that means that if this is 65, this also has to be 65 because those are called corresponding angles. It gets kind of tough. I'm not going to do the rest of these with you just because I don't want to confuse you. So I'm going to stop there for that diagram. Put that in your notes though. Okay, a pair of parallel lines is cut by a transversal as shown. So they have to tell you they're parallel because we're looking for relationships now. Now this is a little tricky. I want you to look at something here. Notice this angle right here, which is not just one angle, it's really both of those together. So x plus 20. Okay, x plus 20 on this side of that transversal is related to this side. Remember, they're both inside, they're both interior because they're inside the parallel lines. And they're not on the same side, so they're called alternate interior angles. And remember, alternate interior angles are always equal. So that means that I should be able to take whatever this is, x plus 20, and it should be equal to 80. So if I solve that, I subtract 20. That tells me right away that x has to be 60 degrees. So that's your measurement of x. Okay, this question says, what is the measurement of angle CED? So first step is to find CED. So let's do that first. C, E, and D. So CED is right here. So let's compare it to the other triangle and see what we know. Now notice that this is equal to this, okay? Now also notice that this will be equal to this, and that's because those are called vertical angles. So those will always have the same measurement. Doesn't matter what it is, they will be equal. So right now you know that this angle is equal to this one. You know this angle is equal to this one. And remember, in a triangle, angles always add up to 180. So if these are the same in a triangle, when you subtract it from 180, whatever you get would be this answer. And it would be the exact same thing for this. So these two triangles would actually be similar. They would be or congruent. In other words, that means all of the angle measurements would be the same. So angle CED would be y degrees. All right, this question says, which relationship is always correct for the angles PQ and R of a triangle? All right, so what this question is really making sure you know is something called the exterior angle theorem. And what that says is exterior angle theorem says that in this case your two remote angles, which means your angles away from this one, always equal to your last. So in that, what that means here, let me write this out so you can see, because I probably just confused you, is angle B, which is Q here. So Q degrees plus R degree is equal to P degree. In other words, if this was 30 and this was 50, we know right away, knowing nothing else, we know that we could do 30 plus 50, which would give us 80, and we would know right away that P would be 80. That's called the exterior angle theorem. And so you want to have that in your notes so you know that the outside angle is always equal to adding up these two inside angles. All right, I hope this helped. This lesson can be pretty challenging. There's a lot of vocabulary words that are new to you. Just write those in your notes, make index cards so that you know them and you understand the relationships. And then just let me know if you need any help. You can call me, you can text me, or you can email me. Good luck on the assignment.